viewers, welcome back to this amazing tutorial class. Today's class is going to be based on calculus. Now, in calculus, we have two different types of calculus. We have the differential calculus, and we have the second aspect, we have the integral calculus. But the one we are going to be talking about today is just the differential calculus. Now, the differential calculus is not actually complete before we can arrive at the first principle. Okay, now let's consider x and y axis. This is the x axis and this is the y axis. Of course, if you have to plot a slope on an axis like this, you always have a curve. Let's assume this is our curve. Then on that curve, you position a right angle triangle. That is, you make out a right angle triangle, just a triangle like this. Then from here to here is simply change in y. Then from here to here is simply what? Change in what? X. Okay. Now from this point, we can call this point, we can call it point A and point B. Right? This point comprises of both x and y, that is the y and x axis. And this point comprises of the change. That is, there will be an increment in both x and y, because as you look at this curve, for example, it's actually increasing. So there's going to be an increment in both x and y. So we can call that increment, we can call it delta what? Y and delta x. So therefore, we are going to have x plus delta x, comma, y plus delta what? Y. Okay? Now, from this point, to this particular point here, let's consider it as fx, function of x. Then from this point to this point, look at it. From here to here is fx. Then from this point to this point is simply f of this x plus change in what? X, because we are actually considering x. Assume we are considering y, it will have been f of y plus change in what? Y. Okay? Now, slope, or simply known as gradient, is given by, slope or gradient for AB is given by change in y over change in what? X. Now, change in y is simply from here to here, and that represents what? F of x plus what? Delta x. Then minus, from here to here, that's f of x all over this delta x. Okay, now this particular formula is known as the first principles. First what? Principles. Okay, but we can represent this the notation of formula, we can represent it in two ways. We have the Leibniz notation and we have the what? The functional notation. Now the Leibniz notation is simply using the y, the x to be equal to this first simple formula, which is f x plus delta x minus f of x all over delta x. Then you now consider limits delta x 0. This is what they call Leibniz notation. But the functional notation will take this form. Functional notation is simply turning this dy dx to function of x to be equal to the first simple formula, which is f into x plus delta x minus f of x all over delta x. Also limit delta x equals to 0. Because as delta x changes to 0, then dy dx or function of fx tends to be at limit level. Okay, now let's take an example on this. Okay, example 1 on this using first principle. Example 1 says differentiate x raised to power 2 using first principle. Okay, using first principle, we are differentiating x raised to power 2 using first. So I can use either this or this. This is my equation, right? I can represent my equation to be fx. That this function of fx is actually equals to x squared. Now, for us to use this first principle, what do we need? We actually need the f although we know the fx, so we actually need the f. The f here is always equals to the coefficient of whatever variables you have here. That is, the coefficient of this x square is simply what? 1. So our f in that case is simply 1. Again, for us to get the f, it simply means that the coefficient of any variables you have, that this coefficient, what is at the back of that variable, is simply representing just f alone. Then the fx is actually everything based on what we have here. Fx is actually everything here. Are we together? So therefore, if you are to use this formula, we have fx plus delta x minus f of x all over delta x, right? Then don't forget limit delta x is 0. So if I'm replacing these parameters here now, that means my f is 1, which can be neglected. Or for the sake of getting this point, just simply put it 1, which is my f. Then into brackets. Now, this x plus delta x here, it simply represents the whole of this function. So I'll just simply put x plus delta x back. But the x plus delta x in this case, because the x here is having a power of 2, put the power of 2 like this. Are we following? The f represents the 1, then the x plus delta represents the variable, which is x, which is this. Then the square, because it's having square, you put it on top. Then minus. Now, fx means, like I said, means everything here. That's x squared. Then everything over delta x. Okay? The challenge we can have here is that we need to actually simplify this one in bracket. That's x plus delta x raised to power 2. So we can use our two methods. We can just use direct method, or we use the what we refer to as the Pascal triangle. That's Pascal law. But if you have to use direct method on this, it's just very simple. From what we have here, we have 1. Of course, square means you're actually bringing the bracket into 2 places like this. As you can see, this is written in 2 places. Then minus x squared, everything all over delta x. Are we following? Then we open this bracket. How do we open the bracket? We simply have, now, for you to open this bracket, like I said, you have 2 ways. Either you multiply direct, or you just simply bring one of the variables and multiply the second values, second variable multiply second values again. But direct method is just very straightforward. Let's just pay attention to that. Okay? X times x, that's what you multiply first. This x times this x, you actually have x squared. Okay? The x again, this first x here, multiplying the second variable here, which is delta x. X times delta x, you actually have x delta x. Now, take note of something here. X and delta x are not the same. So you cannot say x times delta x and you not say this x, since x is multiplying x, will be delta x squared. That is very, very wrong. So x delta x is actually x delta x, not delta x squared. Okay? This multiply this, we have this. This multiply this, we have this. Then the next one you have to multiply is this and this. And but please take note of the sign. Delta x times x, same thing, still give you x delta x, right? Then lastly, you have this delta x times this delta x, and that's going to give you plus delta x all raised to power 2, because they are now the same. Okay? Then minus x squared all over delta x. Are we following? Okay. Now, from what we have here, let's kindly simplify this. We have our x squared plus x delta x plus x delta x plus delta x all raised to power 2 minus x squared all over delta x. Now, look at what we have here. We have like terms here. This and this, they are like terms. But when you bring them together, it's actually x squared minus x squared, and that simply gives you what? 0. That is out. We have another one again, which are like terms, this and this. So x delta x plus x delta x simply gives you 2x delta x. Then plus delta x all raised to power 2 all over delta x. Now, the next thing you do is that you simply factorize the one up, which is the numerator. Okay? Delta x is common to them. You bring delta x out. Then you have 2x here, which is, when you bring delta x out, you get left with 2x, right? Plus, now, don't forget that this actually comprises of delta x times delta x. So if I bring one delta x out, I'm still going to have another delta x inside. Then all over delta x. I hope you are good. Okay, fine. This we eliminate this. Of course, we are going to have 2x plus delta x. But remember, we said limit delta x equals to 0. Limit delta x tends to be 0. So anywhere I see delta x here, I'm going to introduce this 0. So that means I'm going to have 2x plus 0, and that's going to give me 2x. And that is the final answer. So the dy dx of x raised to power 2 is simply what? 2x. Okay? It's simply 2x. Okay, this is example 1. Let me take one more example. That is a little bit complex. Okay? Let me take one more example. Okay. Now let us assume we are given 3x raised to power 3. The same instruction using first principle. Okay? First thing you need to understand is that first principle formula is, this is example 2, f into x plus delta x minus f into x all over delta x. Then you take limit delta x tends to be 0 again. Okay? Now, remember I said for us to get this f is simply the coefficient of that variable. The question given to us was 3x raised to power 3. That's fx is equals to this. This was the question. 3x raised to power 3. So this 3x simply represents f. So if I replace f as 3 in this formula, of course I'm going to have 3 into bracket, then this x here represents the whole of this. X plus delta x, then the power here is simply what? 3. Minus, now the whole of fs represents this. 3x cubed all over delta x. Now the challenge here is that the one we did earlier was just power of what? 2. But here now we have power of 3. Now how do we do this? Of course you can also do it direct, but in this case it won't be perfect that way. So that's why you need to understand Pascal triangle. So in my next class I may introduce Pascal triangle. So that's why you need to just please like, share and subscribe to this channel so that to get more updated on my next videos. Okay, now if I bring this out, x plus delta x all raised to power 3. We want to expand the bracket. Now we apply Pascal triangle here, like I said. Pascal triangle here is that this is 3. Form 1, 1, 1. That's 3 on this side. The same one here, 1, 2, 3 on this side. Of course, there is one up here, a constant one here, but the one is not in there because it's simply raised to power 0. So that's why I clearly start from 1. Since my power here is 3, so I'll have my 1 to be 3. So for me to fill up the middle here, okay, I'll just say 1 plus 1, that's 2. Are we following? Then you can actually see that this particular second line here is having 3 digits. The next one must be 4 digits. How do we get that? 2 plus 1 is simply 3. 2 plus 1 is simply 3. So this is the coefficient that we are using to expand this. So if I expand this, then I have x raised to power 3. That is, I'm using this first coefficient, which is 1. Plus the second coefficient is just simply 3. Then in this case, x will be decreasing. And delta x will actually be what? Be increasing. Look at it. 3, then x decreases, then delta x here. Plus another 3. X decreases to power of 1, then delta x increases to power of what? 2. Then lastly, 1. Then x decreases to power of 0. Don't forget this is 2, 1, and this is 0. And delta x increases to what? 3. So when you are expanding, you must take note of something. The first value here, the power of first value here must be equal to the power of the last value here. So if I finalize this now, I'm going to have x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Because anything raised to power 0 is actually what? 1. So if I bring these parameters here, if I introduce it back into this equation here, I'm going to have something like this. 3 into bracket. So wherever I see this, I'm going to introduce the whole of this. So that's going to give me x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Right? So let me rub off this part, sorry. Okay, now we actually have this. So don't forget, this is just this. Then close the bracket, minus 3x cubed all over delta x. Let's open the bracket here. We are going to have 3 times this. That's 3x cubed. This times this, 9x squared delta x. Then this times this, 9x delta x squared. Then this times this, that's 3 delta x cubed minus 3x cubed all over delta x. So you can see 3x cubed and 3x cubed. That's this minus this. That's out. Okay, very interesting. Okay, now look at what we have left. The common factor there is simply what? Delta x. So if we bring delta x out here, we have 9x squared left out here plus 9x. Then this is delta x. We bring one delta x, so I left with one delta x, right? Then this delta x again is out. You will be left with 3 into delta x squared, then all over delta x. So in that case, we can eliminate this and this. So our last okay, we have 9x squared plus 9x delta x plus 3 delta x squared. Then we now introduce limit that says that what? Delta x tends to be 0. So anywhere we see delta x here, we put 0. So this is actually going to be 9x squared plus 9x bracket 0 plus 3 bracket 0 squared. And that gives us 9x squared plus 0 plus 0. And that final answer gives us 9x what? 9x squared. So this is our final answer. Okay, my people, we need to stop our class here. So in my next videos, we will take at least a little bit difficult question on calculus. So, but please don't forget to like, share, and subscribe to my YouTube channel, because that's the only thing that will guarantee you to see my next videos. Okay, thank you very much and enjoy the rest of the day. Bye.